everyone. So by the way, I am Christian D. Casusi, and the rest of my members is Limuel Berola, um, Julian Murga, and Janine Rinyos. So we are BSCS 3A. So in this time, mag-report me sa mga code bahin sa final project for learning activity 3.2, which is the algorithms and complexity. So this code is certainly this is a Java code. This is to design and to find the minimum sum of absolute differences between the corresponding elements of two arrays. So by arrays initialization, it will take over of the rest of our members limit.
So as you can see in the screen, so we have arrays initialization, and array 1 we have 1, 3, 7 and 9, and array 2 we have 2, 5, 8 and 9. These two arrays are initialized with integers value. So for the main method for this code, we have int min sum is equal to find sum absolute differences, array 1 and array 2. System out print line minimum sum of absolute differences plus min sum. So for the main method, the different min sum of absolute differences method is called with the two arrays. The result minimum sum of absolute differences is the printed.
So in addition, the main method it also serves as the entry point of the program. With this, it initializes the two arrays, calls a method to calculate the minimum sum of absolute differences. So between the corresponding elements of the arrays, and then prints the result to the console. So the primary purpose to demonstrate the functionality of the find minimum sum of absolute differences method using example arrays.
Moving on, find minimum sum of absolute differences method. By showing the screen, private static int find minimum sum of absolute differences int array 1 and int array 2. Sort the arrays sort 1 and 2. Calculate the sum of absolute differences down to return sum. Their explanation: sorting arrays, both input arrays array 1 and array 2, are sorted in ascending order using arrays sort. Calculating absolute differences, variable sum is initialized to 0, then a loop iterates over the elements of the arrays. For its corresponding pair of elements, the absolute difference is calculated using math abs and added to sum.
The minimum sum of absolute differences is then printed in the main method. This code aims to find the minimum sum of absolute differences between corresponding elements of two arrays by first sorting the arrays and then summing up the absolute differences.
So moving on to the next video, we have the Dijkstra's algorithm. As we can see, we have 8 vertices.
There are 8 vertices, just like L, M, N, O, P, Q, R, S.
So now, ato ang i-define tagsa-tagsa kaning Dijkstra's algorithm. So sa nakita ninyo dira sa graph o diagram na ay naka-highlights nga naka-bold ang circle sa L, M, N, O, R, and P. Then naka-color red ang arrow na nag-connect ana sa akong giingon sa naga-bold na circuan letters. So we will be defining kung yun sa pagkuha ng 0, 1, 3, 4, and then 4, 6, 5, 6. So, sa letter L, sa pagkuha sa 0, it is given. So, automatic na siyang 0 dira since wala nila ang kasunod. So, pag L nga to sa M, of course, automatic 1 because ang traveling niya is L to M is 1. So, nakita nyo dira, butangan lang na siya og guide. By moving on into M nga to sa N, of course, ang naa sa M sa ibabaw is 1. And then, the distance is 2. So, i-add lang na nimo. 2 plus 1. So, mo na siyang 3 ngadto sa N. So, ni answer siya og N because gi-add nimo ang distance sa 1 and 2. Moving on into N ngadto sa O. So, the distance N ngadto sa O is 1. And then, of course, sa N, we have 3. So, 3 plus 4. So, the result is 3 plus 1 rather. So, the result is 4. And now, so sa gi-highlight nga color red, balik ta sa N. N, the distance into R is 2. So, to came up into 5, of course, gi-add na to ang 3. And then the distance is 2. So, 3 plus 2 equals 5. Moving on into the R, into the distance of Q. So, makita lang dira, ang distance nila is 1. And then, we have 5. So, 5 plus 1, that is why nahimo siyang 6. And then, R, into the S. So, ang distance nila is 1. So, there are 5. So, 5 plus 1, of course, 6 again. So, now, ato ta sa letter L. Balik ta sa L, na is 0. And then, L nga to sa P, the distance is 4. So, since 0 man na siya, so 4 plus 0, it's wa man siya ma-add. So, again, i-copy lang ang distance nga to sa 4. So, that's why ni sum up siya tanan o kanang 0, 1, 3, 4, and then 5, 6, 4, and then 5 nga to sa 6. So, as finish, nakita dira tanan nga there are some arrows nga gina-pull out. So gipabilin dira ng arrow nga to sa LP, then RQ, then RS, and then LM and O. And gibilin pud itong distance nga mo siya nagamit sa pag-add, which is 1, 2, 1, and then 4, 2, and then 1, 1. So if kuan mangita ta sa the nearest o kanang kinagamyan nga sum up sa tanan like L ngadto sa S, of course diri ta mag-agi sa L, M, N, R, S because gikan sa L i-add nimo ng 1 and then ngadto sa M the 2, so equals 3. And then 3 plus 2, 5, and then plus 1, that's why 6. So mo na siya ang pinaka-nearest o pinakagamay o mas duol siya nga sa pag-locate sa Dijkstra algorithm. So that's why we have L, M, N, R, S.